Significant digit rules. Significant digits are those digits that carry meaning contributing to its accuracy. The digits 1 to 9 are always significant, meaning that 54, for example, will have two significant digits. 985 will have three significant digits. 9, 8, 5. For those three digits, it will have three significant digits. Now 0 is a little bit tricky because 0 may be significant or may not be significant depending on where it appears and in which number it appears. These are some rules for significant digits for 0 as a digit. If 0 is embedded between two significant numbers, meaning between two non-zero numbers, they will be counted as significant. So for example, 2003 will have four significant digits. 2003. Similarly, 20,005 has five significant digits. 20005. While trailing zeros at the end of the decimal number are significant, meaning that, for example, 2.100 will have four significant digits. 1, 2, and those zeros will count. So if a number has a decimal in it, the zeros at the end will count significant. Another example I have here is 7.83060. So all of these zeros will be counted as significant. This zero is between 3 and 6, so we count that. And this zero is at the end and the number has a decimal in it, that will also count. So in total, we have 6 significant digits. Now, the zeros at the end when the number does not have a decimal, it's a little bit tricky. It depends on how it is. It could be significant, it might not be significant. What I mean by that is, for example, 8300, the way it is written, it will only have two significant digits. 83, 8 and 3, and then 00 will not count. However, if I specify it, I can count the zeros as significant. What I mean by that is, if you want that 0 to be counted as significant, we have to put a dot or bar on that 0. Meaning that, for example, 8300, same number, initially the way it is written, it's only two significant digits. But if you want to make it three significant digits, I need to make this 0 significant by putting a bar on top like this. So now I will count 8 as 1, 3 as second, and this 0 as three significant digits. If I want to make that same number 4 significant digit, I need to write bar on the last 0. As soon as I put bar on the last 0, the previous 0 automatically becomes significant because it is between two significant digits, 3 and this 0. So now this number 8300 with bar on top will have 4 significant digits. Leading zeros are never significant. So 0.000, so all these zeros are not counted. 7, 3 will have only two significant digits for 7 and 3. For 0.0123, only three significant digits for 1, 2 and 3. Now let's try to state the number of significant digits for each of these following. 56,208 will have 5 significant digits. Why 5? Because 1, 2, 3, 4, 5. The 0 will also count. Okay. The one here will have, because the number has a decimal and there is a leading number which is a significant, all numbers after that will also count. So we'll have 1, 2, 3, 4, 5, 6. We will have 6 significant digits. So we will say 6 significant digits. For this one now, 140,000, it has no decimal in it and it has no bar on any 0. So only significant digit it will have is 2 for 1 and for 4. Okay. Next one then, 0.000506, the leading zeros are not counted, and then 506. So in total it will have 3 significant digits. Okay. For 58.00 now, because the decimal is there, the zeros at the end will also count. The trailing 0 will count. So in total, we will have 4 significant digits. And for this one then, 0.010690, the leading zeros will not count. The number has a decimal in it. So once we hit 1, we count all numbers after that. So 1, 2, 3, 4, 5. So we'll have 5 significant digits. Rounding rules. To round, for example, to round 670.10308 to 5 significant digits, basically I look at the 6th digit. Because I want to round it to 5 significant digits, I look at the 6th digit. So 1, 2, 3, 4, 5, 6. If the 6th digit is 5 or more, the previous number goes up by 1. If it is less than 5, like between 0 to 4, you just take first 5 digits and that's your result. So in our case, if I want to write this in 5 significant digits, I will cut number 308. I don't care about any numbers after that. So my number will be 670.10. Now if I want to round this number to 3 significant digits, I will again look at the 4th digit after the number which is non-zero. So I cannot look at 1, 2, 3 and 4th number here. I cannot do that. I have to start with first significant number. So I look at this number 4 and then 2, 3 and 4. So I look at the 4th digit. Okay. I look at the 4th digit, and because it is 8, which is 5 more than 5, I round 6 to go up by 1 to make it 7. So basically we get 0.00497 as 3 significant digit number. Now the examples I gave were with decimals. If it is without decimal, we have to be a little bit careful. So my example here, if I want to make this 4 significant digit, I look at 5th significant digit first. So 1, 2, 3, 4, 5. Because the 5th digit is 5, I will round the 6 up by 1. So I'll make it 7. So I get 5, 7, 3. So first 3 digit remains same and the 6 became 7. Now this is 57,365 and this is only 5,737. The number has to have 4 significant digits, but it has to be closest to this number. This is 57,365. If someone owed us $57,365, they cannot just give me 5,737. That will be very little and I'll be in loss. So to make it very close to this and 4 significant digit, I must add 0. So now this number is closest to this number, the new number is closest to this number and it is 4 significant digit number. Similarly, if I want to make same number in 3 significant digit, I look at the 4th digit which is 6. So my previous number will go up by 1. So I'll get 574. So now the new number has 3 significant digits. But is it close to this? No. This is 57,000 something and this is only 574. So I must add 2 zeros to make it equivalent to that. Why did not we do that here? Because the number is in decimal, zeros after here will not make any difference in terms of getting closer to the actual number. However, if I added extra zeros here, it will increase my significant digits from 5 to 6 or 7. So we cannot do that. It's only when it is whole number. Okay. For C then, 2020.62, I want to make it 5 significant digit. So 1, 2, 3, 4, 5, 6. I look at the 6th digit. Because it's 2 only, I just totally ignore that and my number here will be 2020.6. It is 5 significant digit and closest to that number. For this one then, to 1 significant digit, I look at the second significant number which is 8. It will round up 1 to become 2. So now I have a number which is only 1 significant digit. But is that close to 18? This is 2. 2 and 18 are far away. 20 will be the number which will be closest to 18 and it will have only 1 significant digit. Same number, if I want to make it 3 significant digit, I'll look at the 4th significant number which is a 3. It will not change the previous number. So my answer will be 18.0. It is closest to given number and it has 3 significant digits. Is 18 and 18.0 same? No, 18 has 2 significant digits, while 18.0 has 3 significant digits as we require. Lastly then, 19.00, if I want to make it to 2 significant digits, I look at the third number, which is a 9. So it will round this 9 up by 1, but that 9 will become 10. It will round up this 1 by 1. So in total, we get 20. 19.99 is closest to 20. However, 20 only has 1 significant digit. We needed 2 significant digits. So how do I make 20 become 2 significant digits? If we want to make any digit to become the 0 to make it significant, count as a significant digit, we have to add bar on top. So if I write 20 as this, compared to what I had previously, this 20, the new 20 is now 2 significant digit number. Okay. Lastly, how do we round numbers? When we end up multiplying or dividing two numbers, or even taking square root of a number or square of a number, we round our final answer to the lowest number of significant digits from the question. Meaning that if I had 5 numbers being multiplied, divided, taking square root and things like that, I look at significant digit for all 5 numbers. And the number which has lowest number of significant digits, the final answer should have that many significant digits. How about adding, subtracting? If I add or subtract numbers, I will round my final answer to the lowest number of decimal place from the question. Meaning that if I had 3 numbers being added or subtracted, if the lowest number of decimal places in the question had 2 numbers after the decimal, the final answer should have 2 numbers after the decimal. But what if I had numbers which had adding, subtracting, multiplying, dividing all together? If we had that, then you look at what is the last operation. Whatever was the last operation, that's what you do. So if you were adding at the end, you will look at number of decimal places. If you were dividing at the end, you will look at number of significant digits. Okay?